So this is the 2024 Higher Level Maths Junior Cert paper, and it is question 13. So Michael is designing the roof of a house. The width of the roof is 6.1 meters. The roof will be in the shape of a right angle triangle of height h, where h is real. Michael can choose different values of h. The diagram below shows one possible design for the roof not to scale. Calculate the slant height x, so we've got to calculate the hypotenuse, correct to 2 decimal places. So very simple stuff. This is just theorem of Pythagoras. So it is 6.1 squared plus 2.84 squared is equal to x squared. When you do the left hand side, you'll get 45.2756. Square root both sides, and that will give you, to 2 decimal places anyway, that I'd say approximately equal to 6.73 meters. Okay, part B. The diagram below shows a different design for this part of the roof, not to scale. Use trigonometry to work out the size of the angle marked theta in the diagram. Give your answer in degrees, correct to the nearest degree. Okay, so they're telling you what to do here. So we've got to find theta. So theta is going to be, in this case, the tan inverse. So we're going to use tan here because we have the opposite, we have the adjacent. So what we've got to do here is tan of theta is equal to 3.12 over 6.1. That just means that theta is going to be the tan inverse of 3.12 over 6.1. So you can just do that on your calculator. Just make sure your calculator is in the right mode, and you'll get 27.088, and we are asked to find theta to the nearest degree, so it's just going to be equal to 27 degrees. Okay, so let's move on to the next question. A different part of the roof is in the shape of an isosceles triangle with base 14 meters. In this part of the roof, Michael makes an attic room by putting 2 vertical sidewalls AB and DC. So they are these two here, shown in the diagram below, not to scale. The distance from B to C is 8, so this distance here is 8. Total height of the roof is Y, so this is Y here. AB is equal to DC, and which is equal to X meters. X and Y are both real. Use similar triangles to show that X is equal to 3Y over 7. So we've got to look for similar triangles here. So what I'm going to do is just cut this whole roof in half, if you like, down the middle. And we're going to look at this triangle here and this triangle here. They're both similar triangles. So why is that? Well, let's have a look at them first. We know that the distance from here to here is going to be half of 14, which is 7. So that's going to be 7 meters from there to there. And then we know the distance from here to here is going to be half of 8, which is 4 meters. So that's the distance from there to there. We have X here and we have Y here. Now, I don't think, but I'll go through it anyway, that you're required to actually show that these two triangles are similar. But let's do it anyway. We're looking at A, B, C, D, E. So I'm going to call this corner here F and this vertex here G, but I won't need G actually. I'm just going to use this side of the roof. So let's just prove that they're similar first. I don't think you're going to be required to do this, but I'll do it anyway. So let's just redraw them. So we'll call this F. We've got A here, we've got B here, got E here, and actually I'll put G down here. So I'm going to call this G here. So we know that this is going to be parallel to this here. Why? Because we know that AB is vertical and E down to G is going to be vertical as well. So we can say that the triangle AFB and EFG are similar. So the triangle AFB and the triangle EFG are similar. Since, let's see, we can say that the angle EFG is equal to the angle AFB, Why? Because they're a common angle. We can also say that the angle ABF is equal to the angle EGF. They're going to be 90 degrees, and that's kind of given in the question. We're told that AB is vertical and EG is going to be vertical anyway. Therefore, let's see, angle FAB is going to be equal to angle FEG. Well, two reasons: they're corresponding angles anyway, and also we've already shown that two angles in the triangles are equal, so the third one must be equal. So two reasons why these two angles are equal. So I'm just going to say angles in a triangle. That would be the proof there, if you like, that those two triangles are similar. So let's answer the question then. Use similar triangles to show that x is equal to 3y over 7. So let's just put in what y is and so on. So y is this side here, so that's going to be y, and we need an x as well. This is going to be x here. Now I'll just separate out those two triangles. So we have the small one, which is FAB, that's a right angle triangle there. We know that that side there is going to be x, and the length from here to here is going to be 7, which is from here to here, minus 4, which is from here to here. So this distance here must be 3. This is 3 meters. And this is x meters. The larger triangle then, which is F, E, and G. Right angle is down here. So the sides are, y is the vertical one, and the distance from here to here is 7 meters. So our two sides are y meters and 7 meters here. So these are our similar triangles. That angle is equal to that angle is equal to that angle, and we have two right angles as well. Okay, so let's just use similar triangles to show that, to show that x is equal to 3y over 7. So we can say x over y is equal to 3 over 7. So in other words, this side divided by this side is going to be equal to this side divided by its corresponding side, which is this side here. And we can just multiply across by y, which gives us x is equal to 3y over 7. And that's it. I think that's all we were asked to do. Use similar triangles to show that x is equal to 3y over 7. So the area of the shaded region ABCDE in the diagram is 12 meters squared. Using your answer from part C1 or otherwise, work out the value of y. Okay, so let's just draw that. We had a rectangle, and then we had a triangle up here. So that's the shape that we're looking at. We know that this distance here is 8 meters. We know that this was x and this was x meters, and we know the distance from here to here was y meters. So what I'm going to do here is I'm going to split this up into, as I say, a triangle and a rectangle, and I'm going to work out the area of both and add them together. So the area of the rectangle is just going to simply be x times 8. So in other words, the 12 here, remember the area of this entire region here is 12, so 12 is going to be equal to 8 times x plus the area of the triangle at the top. The area of a triangle is half the base times the height. So that's going to be half of 8, because remember this distance is 8, so this distance here must be 8 as well. And now we've got to find the height of this triangle. So we're going to look at this distance here. So what is that distance? So that distance there from there to there is y. So we've got to take y and subtract x. And that's how many meters that is. Okay, so because the distance from here to here is x, the distance from here to here is y, so we just subtract them. So it's going to be y minus x. Okay, so let's just work out y then. So we have to, let's see, 12 is equal to 8x plus half of 8 is 4, multiplied by y is 4y. Half of 8 is 4, 4 times x minus 4x. That'll give me 12 is equal to 8x minus 4x is 4x plus 4y. Now we've got to work out what y is, but remember up here we worked out what x was. X is 3y over 7. X is 3y over 7. So I can put that in there. So 12 is equal to 4 times 3y over 7. I gave you a hint in the question anyway. So now all we've got to do, we have an equation there. We have everything in there except y, so we can isolate y. So let's see, we've got 12 is equal to 3 4s 12y over 7 plus 4y. The next thing I'm going to do is just multiply everything by 7. So I multiply 12 by 7, I'll get 84. That'll give me 12y here, and multiply 4 by 7 will give me 28y. That'll give me 84 is equal to 12 plus 28 is 40, so that's 40y. And then finally that'll give me, divide across by 40, that'll give me y is equal to 84 divided by 40, which is 2.1 meters. Okay, and that's it for this question and the higher level exam.